Basar, ciao. Okay. Good afternoon. Today we are going to talk about to finish or chapter 1. At the beginning we have what? Kindly check that. And so we have what we have in the discrete mathematics chapter 1. Let me find him. Yes. Chapter 2. Where's chapter 1? Yeah, maybe here. Yes. Thank you very much. Good. Here we are. We talk about how to find or how to design your things. What's the proposition and how we deal with it, how we play with it. And we took a condition, I remember, conjunction, disjunction, and if then condition, and by condition, if and only if. And we say contradiction, contrapositive, sorry, contraverse, and inverse. We mentioned all these concepts together. Do you remember that? Good. And later I'm going to record with the other group and I'm going to upload for you. So today we are going to finish our duty here. I remember that I talked about that one. Then we saw that one, right? And we stopped here. Am I right, dears? Good. So here we are, we have a truth table for compound proposition. Careful. During the exam, maybe I say use truth table or use properties. So for, as a beginning, for you to understand, use the truth table. Later, we are going to use the properties by 3 lines. Maybe you prove that one. Now we have what? You say what? You say show that one. Show that P or negation of what? Of Q, then, if then means that implies P and Q. So give me the result, show me the result. So before we are doing anything, because we have two statements, let me say, we have two statements P and Q. So we have true, true, false, true, and true, false, true, false. Then we need what? We need negation of Q. Okay, here's negation of Q. And we need or between them. Here's the negation between here and or here. And then later, we need and between these two. Here's the and between them. Then after finding the result, after finding this result, we are going to use then. So we say true, 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 false, false. In case here's a false and here's true, we get false. So true, false, false. False, false, give me the true because it's then, if then, and again, true, false will give me false. Do you have any comments how we did like that? This is the compound. Did you understand yours? Clear, right? Good. Now, precedence of logical operators. What do you mean by that? Means that if I have 5 or 6 operator, which one has got the priority? Which one is the first? So the first, we have a negation. For example, if I say negation P and Q, so which one? I should do which one in the truth table or for myself? The priority is for what? For the negation. Then, for example, if I have P and or Q, let me say that. Let me make it to understand, to be more understand. For example, I have negation P, okay, and Q, or let me say P again. So for that, I'm going to do that one the first. These two, the result of these two. I think you asked me one day, I said just be patient. These two together will be the second. The result of these two together will be with the, or will be the third. Depending on this precedence, priority for negation, then and then or after them, if then after one, if and only if. If you remember, we say if and only if by conditional. If then and if then. When you saw something like that, translate it in your mind. Say if I have P, if and only if Q means that equivalent to what in your mind? equivalent to, right here, P one P if and only if Q is equivalent to what? To P then Q, you'll find that one, the result, and Q then what? Then P, and the result of that one. Understood? Then later we are going to also extract that one, but later, not now. So here's the preceding means that the priority of the operator in the logic operator. It's a logic operator, we mean and, or, then, negation, and that. Do you have any question about the second, that part? Okay, now we have a bit of the operator, a bit for true, we are going to put 0, 1, and for false is what? Is 0, like a switch, like a computer that you are. It's your job, it's your duty with it. Of course. So the same thing is true for here. We can use the true and false, all of them, and it's called a Boolean. A Boolean is in the sub chapter that we have later. We are going to use it more and more. So you can see from here, we apply that when we have true, true, false, false, or false, false, true, 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 false, false, true, like that, as a previous one. And here the same, if I have false and false, or false or false, I'll get what? I'll get false. 1 true, false, 1 true, or 0, 1, I say is 1. 1, 0, because I have or, again is 1. 1, 1, I will get 1. Understood? Did you understand? Good, easy. How about and? The same as a previous. And will be between these two together. If I have and between these, look. We see what? We see that one and that one will give me 0. That one also give me 0. That one 0. And the last one will be 1. Like a true, false. The same things happen for here and for all of them, even the if and non if or if then. And it's called a bit. A bit is 0. So sometimes your example, especially for your department, you see what? You see we have that one. So kindly, for example, find the negation of that one. So this is my P, my statement, and I'm going to find the negation of that. The negation of that one will be what? 0, 1, 0, 1, 0, 1, 1, right? So like that. Each one will be 0. Let me do it nicely for you. Let me do it nicely. Here we are. That one will be 0, 1, 0, 1, 0, 1, 1, 0, 0. Am I right? That's the negation of P, if P is equal to that one. How about, for example, P and or, you can see from here, we have many things. If I give you P and Q, and I say find or P then Q. So how we do it? You can see from here, you see 0 with 1, because I have or, I'll get 1. 1, 1, 1, 1, 0, 1, 0, 0, 0, and go on like that. Did you understand the first line, the first row, dears? Clear? Kaka? Clear? Good, very good. And this is the part of this part that we have. Any question? Later, I'm going to select the exercises for you. Actually, I don't have a time for that, I'm sorry. But later, I'm going to select most of them, okay? So I start with the first chapter. And no worries, the selection will be reflect of your lecture note, as we did before. Here we are. We have what? Propositional equivalence. We know propositional means that P something with a Q something else. So we have 3 concepts here that I highlighted. Tautology. Okay, we have a tautology. Also, as well, we have what? We have what do you say? Contradiction, and we have contingency. So tautology is what? Tautology means that totally true. The result is totally true. The outcome. Understood? I have P. I have Q, I use something, the result is what? Is totally true. How about contradiction? Contradiction means that the result is totally false. That result is totally false. How about contingency? Means that it may be false, depends, maybe true and depends. Can you give me an example on tautology, dears? Can you give me an example on tautology? For example, if I have P and negation P. So P may be true or false. Am I right? How about negation? False or true? Okay. So tell me about P or negation P. True, true, right? True, true. So that one is called tautology. Understood? Understood, dears? Okay. How about P and negation P? It will be contradiction. Why? Look at here. Let me change. Let me change that one to the new proposition. So I say P and negation P. True, false, false. False, true, false. So that one is contradiction. Understood? Clear. So maybe you have many propositions, 2, 3 propositions, and the result is tautology. So that one is called tautology. You can see from here, we have all of them. And another thing we have here is important. It's called De Morgan's law. What's the De Morgan's law? You can see the De Morgan, the name of the mathematician man. So is what we say negation of P and Q will be like that. Careful. Look at here. It's equivalent, means that distribute negation P, negation Q. What's between them? Change to or, because we have De Morgan's law. How about for the second, P or Q? So it will be equivalent, the same, negation P and negation Q. Understood here? So when we have negation to P and or, will be distribute and change the character, change the that one. Understood here? Clear? Sometimes we have it like that and like that. Okay, good. So careful. We have or, careful we have and, without changing the other. Okay. The two compound, what is a tautology called logically equivalent, called two compound, two things, P and Q. We call them, these two statements are logically equivalent. If what? If P biconditional, but a P if and only if is what? Is tautology. If I say if you change P to that one and Q to that one and together and you get something, I say P and Q, they are equivalent. Means that if you find P if and only if Q, the result, the outcome is what is always true, tautology. So show me to understand instead of speaking, right? Learning by do it. Yalla, show me that one. Now I say, show, use truth table to show that these two concepts, didn't we say De Morgan's law? Didn't we say that one are two of them are equivalent? So show me De Morgan's law over or is tautology, is true. That one is equivalent to that one. So in my mind, I have A and B. I say if you want to show A equivalent to B, you should find, you should check A if and only if B, the result is what? The result is tautology. Understood? Good. So here we are. I'm not going to do this table for you because it's easy. Just I'm going to write on it. Yalla Jamaat. True, true, false, true, as usual. False, true, true, false, right? Good. Now I need one. I have that one, right? So P or Q. Let me find that one. So P or Q, we have that one. Then negation of these. I have that one. Good. Now this is your first part. Now find, then try to find negation P, here's negation P, and negation Q, here's negation Q, then and between them. This is will be your, what do you say? Your result. Okay. To show these two are equivalent, that's A and that's B, we should do what? We should find what? If and only if we between them to get what? To get tautology. Understood? So, can you help me how? Do you know how? Just use, yeah, the result. Use the truth table, nothing else. The question is, in your lecture note, say that, listen to me, Kaka. Say that these two are equivalent. Show that by truth table. So use truth table, is that table, to show these two concepts, A and B, are equivalent. You can say that? Okay. If they are 100% like each other, we can say, or theoretically, maybe I say theoretically show it after the truth table showed by a truth table without comparing. So how we find them? I say I have that one. So do not forget FFT. So I say negation P or Q is equal to FT. Am I right? And negation P and negation Q again is equal to FT, right? So I am going to find this one between them. Am I right? Am I right? So for example, actually, I forget about if and only if is equal to what. So how I find it? We got that one, right? Let me show you what I mean. We have this table before. Let me go to there. I don't know where. Show me if we got by conditional. Let me see. If they are both the same, true. If not, both are false. 100% you are right. How about if I forget? And thank you. So if I forget, which usually I forget, so I'm going to use that one. P implies Q and Q implies P. That one is P, then Vandoliv Q. In case you forget. Thank you, you help us more. But in case you forget, you can use this statement also. Understood, Kaka? Good. So let me go to the question again. As you say, so show us the result, yalla. If they are the same, true. If they are different, false. So the result is what? Tautology. So it means that these two are equivalent. Understood? Oh, you got it, dears? So as you mentioned before, if they are 100% like each other, I'm going to combine these two words together. Okay, dear? Hello? Fine? Good. So here we are. There's A, there's B, and we used if and only if we got two true, true, true. So yes, they are equivalent. So how about that one? P implies Q, you can say is equivalent to negation P or Q. Later, I'm going to use this property maybe 10 times. So get it from now. I'm going to use that one maybe 10 times in the properties. Will help me more. So from now, learn that is equivalent to that one. Okay? But here, the question is what? Show me they are equivalent. So you say that if you have P, Q, show me that P implies Q is equivalent, A is equivalent to B to negation P or Q. Am I right? You see that? So I have P, okay, negation, let me say negation P, okay, negation P or Q, then P, then Q. Am I right, Jamaat? So true, true, false, false. As you know, true, false, true, false. Yalla, give me the result. Negation P, so false, false, true, true. That one or that one, that one or that one, true, false, true, true. Thank you. How about that one, then that one? Am I right? So they are equivalent or not? Yes, they are equivalent, because if I use if and only if, I'll get what? I'll get tautology. Am I right? So now I got the concept of equivalent was very important between two propositions, means that the result of them is tautology, big T. Understood, dears? Good, thank you very much. Any question? Fine? Kaka, fine? Good, thank you. And during these, we get something, that one is equivalent to that one, take it because later we use it, later we do like that, so careful. Now, that's the question, using truth table, by using truth table, show that that one and that one are logically equivalent. Again, find that one, make a table, then show that the result is tautology. Shall I do it for you? During the exam, can you solve something like that? Good, very good. And how many statements do we have? 3, right? So 3, 2 to power 3. Am I right? 1, 2, 3, 4, 5, 6, 7, 8. Now you know. That's why the discrete structure is related to you, because 2 to power something, right? Because you have 2 means that you have binary, 0 and 1. That's why we say 2 to the power things, true, false, 0, 1. So because I have 3 persons, 2 to power 3. So how we distribute the table, as you asked before, you can see the answers here. We have 4 true, 4 false. Then the second, couple true, couple false. The third one, single, 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 right? Like that. Understood, Jamaat? Okay. So most of you in this, right? Understood? So we are here and we are here. So you have true table and how to read. And based on that one, you can find them. So look at here. You can see, you see, show that P, Q, R. Now we have Q and R, because and is before or, right? Preceding is say that. So Q and R. Here's the result. Then P or QR. Here's the result. Okay, that one is show that that one is equivalent to B, capital B. Where's B? We have P. Oh, sorry. We have P or Q. Here's it, P or Q. And we have P or R. Here's P or R. Then the result of them, and now I will get B. Then it's time to compare these two are tautology or not. You can compare from the table, as we mentioned. You can do it by your hands. But you see, this is easier. F, true. And they, you can say they are equivalent. Understood, dear? Hello? So, during the example number 3, number 3 and number 4, I gave you two properties. The first one, it was what? We say that PQ is equivalent to negation P or Q, right? And the second, it was what? It was P or Q and R equivalent to what? P or Q and P what? Or R. Like distributing. Can you see? It looked like distributing. Hello? Did you get the idea? I'm talking about the example, but with the example, slowly I give you the property. And I show you. Maybe later I say that is equal to C. How? So the answer in example 2. How? The answer in example, for example, 4. Understood, dears? Hello? Good, very good. Good, dears. So do not forget about example number 3 and 4. They are without example, they are concept. We are going to use them later. Here you are. Look, that's our concept. We prove that one together. So example number 4. Can you see? Right? And where's the other? Later we are going to use them. So this one, I'm going to leave that one also for you, all of them for you, because they are not hard, but we are going to use them. For example, always P and T will give me P. Always P or Q, or P or F will give me P. You can do it. Can you do it? Did you understand what I mean by that? How? You didn't understand. Okay. So I'm going to make one for you. You will get it. So you have P, right? P may be true. When we have capital T, means that tautology. Okay. When we say F, capital F, means that contradiction. Okay, dear? So show me. You say what? You say P and T. So show me here. Show me P and T is equal to what? True. P and T. True. Okay. False, true. I got what? P itself. Am I right? Hello? So how about P or false? Look. P or false. So true, false, true. False or false. So it is what? It's P itself. Now I think you got all of them. Am I right, dears? Oh, good. Now, that one between two equivalents. Now, how about P or true, you'll get true. How about P and F? You'll get F. So you don't need to memorize them. Just do a little bit, 1 second, you can find them, okay? Actually, if you ask me, I should sit for 1 minute to understand, to memorize. So you don't need to memorize it, just do it. And of course, P or P is equal to P. P and P is equal to P. So it means that each thing with itself or an and, it will be the same itself, okay? And of course, this one, if you change the place between P or Q, you will get Q or P. So they are commutative. It's called commutative. How we say 1 plus 2 is equal to 2 plus 1. That one is called symmetry or commutative. So that's a commutative. How about between ands? Yes, P and Q equivalent to Q and P. So they are commutative. If I have 3 things and I can do it, I have 3 things, but careful, the operator the same, right? So look at here, P or Q or R. You can say first I am going to choose these 2 is easier for me, then second I am going to that. Yes, you have a priority, you can do it. By what? By which law? By associative law. Okay, also from here it's called distribute. We have or distribute over and. Look, I say P, these together, we did like that, right? Before, and P or Q here. How about and over? And over distributing over the other. Look at here. We can say what? And. So I'll get P and Q or P and R. That one. Understood, dears? Good. How about De Morgan's? De Morgan's and negation will distribute to others. Negation distribute. How about absorption? So the same. Why? Can you tell me why? Because that one is equal to what? P or P and P or Q. P or P? P itself, right? P and Q or Q. Yeah. Yes. P or P is P. So P or Q. Q and P. So you can see we'll get P also. Or you can see we will get Q, right? Because we will get true and false, false and true. Right? Look at it. No, it's not like that, sorry. P, Q, P or Q. Look at here. True, false. Sorry, true, true. False, false, right? True, false. True, false. Am I right? So when I use R, I'll get what? True, 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 false. So how is that? No clean. I think they are P, I think. No. Later I'm gonna check that one. Actually, I'm not sure about that one. Okay, I'm gonna change it. No, it's not like that. You can distribute them. No, you cannot say that. So that's why. I didn't get, sorry, wait a minute. I didn't get your point, sorry. Uh-huh. Maybe let me do it like that. Why not? Maybe equivalent like that. Yes, you're right. That's the idea. Good idea. Wait, we have what? We have P or P and Q, right? Yes. Let you do it by truth table, yalla. Okay, P, Q, so true, true. Wait, silent. Help us instead of speaking. False, true, false. Now I have and, right? P and Q. I will get what? Right? Then with or, because we can use play with them. So with or means that this result or here, right? P, sorry, you are right. P. Okay, let me highlight them. That one with that one. So the result will be what? By red. Yes. True or true? True. False? True. False. Okay. Exactly. Thank you. It's P. Well done. Tamam. Instead of the property, we use that one and then one. Thank you. So how about that one? Of course, the same. Good. How about that one? We say that total, the total tautology and the contradict. We show that one, right? So here we are. Negations. Do you have any question, dears? Clear? Okay. So this is very important. These two tables. We use this information, these properties, okay, to solve the other things. Oh, sorry. We say that and we show that, right? Because the first and the second that I recorded for you. Understood? So this is the first one. How about that one? Also, you show that one. It was contra positive. Do you remember? The previous one, we say contra positive is what? If you have P implies Q, will change to negation of here, then negation of here. Understood, dear? So it's the contra positive. That one. So how about that one? How about that one? We have many of them. So we are going to show some of them or the other. How about here? As I told you, if I forget, I'm going to use that one. P implies Q and Q implies P. So we should sweep between them. Do you have any question? So that one's for biconditional, that one for conditional statement. So the important thing is here, all of them, but that one is very, that one is very, and that one is also very, and that one. So look at here. Show that that one and that one are logically equivalent. Silent, please. But what's the condition? I say without using truth table. Clear? You cannot use truth table. By truth table, we all know. So you have two questions. Question number one, I say use the truth table. You will find by truth table. Then the second one, without truth table. So how we show that? We have what? We have negation. Negation. P implies Q is equivalent to what? Equivalent to P and negation Q. Yalla. It's like a game. Kindly do it if you can. Can you do it? Or let the first example, I'm going to do it. Then later for the second try, you try, okay? Without looking at the lecture note. Look at here, dear. You start from left to get the right side, okay, dears? Yalla, show me how. I say negation of, here is equal to what? P implies Q is equal to, equivalent to negation P or Q. Am I right? How? Why? Because maybe I say go check here, either. Or the previous example. Do you have any question? And depending on the De Morgan's law, so I'll get negation P and negation Q. Am I right? Hello? Did you understand? No? Okay, I'm gonna repeat it, but quickly. Okay. We say you have that one, show is equivalent to that one. Means that start from left to get right. Understood? Good. Yalla. Or sometimes you can start with the right to get the left. Al-Muhim, you get it. Okay. So I say negation P implies Q is equivalent of negation. I'm just breaking the if and then. If then. How we break it? We say if you have such thing like that, you can say is equal to negation of P or Q. That's the rule. Understood? Good. Instead of using truth table and P, Q, no, direct you can do it like that. And we have such things. If I have a negation, you have and or and or you have it. We can say we are going to use the De Morgan's law. How? We say the negation. Look at the De Morgan's, just for remembering. Here's the De Morgan's. We see the negation will come to all of them one by one. Kaka, negation to one and the negation for the second, and that one will change to what? To and by De Morgan's. Understood? Then of course by the negation rule, negation of negation P, so then negation Q. Now I got left side, right side. Understood, dears? Now we show by using property without truth table, we show that one is equivalent to that one. Clear, Jamaat? Hello? Kaka? Oh, good job. So here we are. Here's the step. You say everything that you want. Can you show that one is equivalent with that one? Kindly. Okay. Without looking at anything, please. Just do it by your mind. Yalla. Yes. We'll do it together. Help us. Okay. Did you get the other side? If you get it, means that you are right. Okay. Together we will do it. Okay. And if you like it, I am gonna check it for you. Okay. No worries. I felt actually. Okay. So look at here. We'll do it together, step by step. Uh-oh. So here we are. I wanna and do something. Good. Yalla. Yalla, let me know. Yalla, Jamaat. How you solve that one? You can say we have what? Yeah, negation P using big De Morgans, right? And negation of, am I right? Good. Let that one be in the other side. So negation of negation, P, or negation Q. Am I right? Then I can distribute that one. I say here for here and here for there. So negation P and P, or negation P and negation Q. Am I right? Kindly use parentheses is better. Then I'll get what? No. Think about it. False. You will get false. Right? It's contradiction. Negation P and P will give you false. Can you imagine how? Why? Good. Or negation P and negation Q. Am I right? And false or something will give you itself. We say P or F will give you P. Am I right? So again, means that false or something will give you the same thing. Let me change to A. So we'll give you A to understand. Yeah. We'll give you the, right? To give you the itself. So this one with that one will give you the same. So we'll give you what? Negation P and negation Q. So depending on that one, we show what? We show they are equivalent. Okay, dear? You can see that one or that one the same. And you get the result. Do you have a problem with it? So I'm gonna leave example 8 as a homework. Okay, dear? Do it at home. Example 8, yeah. You say what? What's the question? So in the other side, I have what? T. So show that these from here start, you'll get that one. Shall I do it or you can do that one? Of course, it's very easy, not easy. Yalla. For what? For rest? You wanna rest? So it's recording. Kind is recording. So if you have something and you wanna share, let me know. So I'm gonna give you 10 minutes or 15 minutes. Then you will start again.